Okay, today we are going to learn about the first topic of M1 textbook. It's coming under the projectile. So initially when you are talking about the projectiles, there are different kind of projectiles we are learning about. If a projectile of some kind of a V is working at an angle of theta, we know, we have already learned in our physics, we can write this one as two components. It's a combination of two components along this way, that is V cos theta and this is V sin theta. Hope we have already learned these facts in our AS level physics. For example, if there is a velocity of 20 meters per second happen at an angle of 30 degrees, suppose. So this one you can write this way, 20 cos 30 and this is 20 sin 30. 20 sin 30. So in this case, this one you can write this side 20 cos 30 is root 3 over 2, it's 10 root 3, and this side 10. The vector format of this answer. The certain questions we need to find the, so it's a vector format. Vector format you can write 10 root 3 and this is I component and this is 10. Or you can write this one as 10 root 3I plus 10J. In later on questions, we will understand that what is the use of learning this vector format in this topic, and whatever the other topic also is joined. So in this case, we should learn these facts, right? Then we are going to learn about this concept, that's a projectile at any angle. At any angle, right? So if you come up with this, you can see, yeah, these concepts also we have already learned in our AS level work physics. So if you come up with a question over here, the particle be projected from a point O on a horizontal plane is 28 meters per second at an angle of 30. They ask about find the greatest height and the time of flight and the distance of OA, 28 and 30, right? So in this case, this is 30 and this and velocity is 28 meters per second. Now you can realize that this is following up some kind of a parabolic path. So this is the vertical range they are referring to, and they ask about the maximum height. Maximum height is this bit, right? This velocity you can write it as a two components, horizontal component over here and a vertical component over here. That is 28 cos 30 and this is 28 sin 30, right? Okay. To find the maximum height, we are referring to the learning about the vertical component. The vertical component, the initial speed is 28 sin 30, it's to the vertical up. And at the maximum height, the theory we know is the final velocity becomes zero. It's the concept we use. You can write V is equals to 0. And we need to learn about the acceleration. Since it's 0, there is no direction we should concern about. Acceleration, we know that it's downwards 9.8. Therefore, if you apply, so we need to find what is the value for S. So the relationship between UVAS would be V squared D equals to U squared plus 2A. Remember that, children, it's a vector equation. Therefore, we need to apply the direction. So I'll just consider upwards components as positive for this question. So there is nothing called we apply upwards V squared equals to U squared plus 2S, because the motion is going up and down. Only this vector indicates you that we consider the upwards components as positive. That's a factor to understand. So this is 0 squared is equals to U squared is 28 sine 30 whole thing squared plus 2 into, this is minus 9.8 into h is the fact we need to find it. Then if you simplify this, you will realize that you just simplify and see h become maximum height would be, let's work out and see, it's 10 meters. That's a fact we need to understand, right? Okay. Then this is the first part of the question. They ask about the maximum height it reach. Then the second part of the question they are referring is the projectile duration or the time of flight. Right. That is the time taken to travel from here to here. Now, in this context, we need to understand, children, if you consider the vertical motion, over here the vertical displacement is 0, over here is this bit, over here is this bit, over here is this bit. Like that, its vertical displacement become like this. It comes to this point, then, so this is the point where the time of flight is over. At that point, we can understand that vertical displacement is 0. U is 28 sine 30. If you just simplify, you will understand this is 14. Just put it the capital and see. It's upwards. And A is downwards 9.8. So we can apply the formula. The fact is the time of flight T. So we can apply upwards SC equals to UT plus half AT squared. So in this case, you can say SC 0, U is 14T plus half into minus 9.8 T squared. So 0 equals to 14T minus 4.9 T squared. So in this case, since the time is not equals to 0, T cannot be 0. Therefore, you can cancel 1T with 1T. Therefore, it's turned up to 14 minus 4.9 T. So you can cancel 1T to T over here. With this, you get the answer. Time of flight would be 2.857. 857 seconds. Right. Okay. Then the next part of the question they are referring to is to find the horizontal displacement. See, for the horizontal motion, we know that over here, when it's traveling a vertical height somewhere over here, it travels horizontally up to a distance from here. It is the same. The time of flight is the same thing for the distance traveled for a horizontal range of capital R. So what you need to understand is horizontally, for this case, we refer with there is no horizontal acceleration or deceleration. We consider that horizontal velocity component is same. It means it's moving with a constant velocity. That the assumption we use, but practically we know that due to air resistance and all other facts, it can be, it would be not equals to 0 sometimes, but theoretically we consider, unless it's mentioned any facts referring to that, we just use this as a, it's moving with a constant velocity. So initial speed is 28 cos 30, that is 14 root 3. Acceleration is 0, there is no acceleration. Time is 2.857. We need to find what is S. S means the range. So horizontally, what we can apply, SC equals to UT. It's a simple way of doing this question. So you can say R become, U is 14 root 3 into, this is 2.857. So you will receive an answer for R as 69.28 meters. Just work out and see whether 28 meters. So that is the initial part of the question where we have to understand in this kind of a context. Right. Let's move on to the next part of a question. Sorry, next question. Next part of the question. So it's like this. So this projection has made the particle is projected from point O with speed of v at an angle of elevation of theta, where tan theta is 3/4. So from this context, we can understand about the angle, because if you know the tan theta is 3/4, we can get any component of sine theta and cos theta. We have practiced some similar question in our mathematics, right? The point O is 4.42.5 meters above the horizontal plane. The particle strikes the plane at point A. After 5 seconds is projected. Show that V equals to 20 and find the distance between O to A, right? Now let's start with this question. So this is the information where we have it. The particle strikes in the point A. Point A means at the bottom of this one after 5 seconds. So we need to get this component. So initially, let's start with this question in this format. From this platform, it travels at a speed of V. It goes like this and reach the ground. So what are the information we have it with it? So initially, from this one, you can make two components, V cos theta and V sine theta. So we know that tan theta, in this question they have given, tan theta is, 1 second, it's 4/3. That means it's just like this. 4/3. So if I apply the Pythagoras theorem, it's 5. So sine theta is 4/5 and cos theta is 3/5. Right. So initially, you know that what are the facts to be learned? We know that u is upwards v sine theta. That is 4/5v, 0.8v. 4/5, 0.8v. So, and acceleration. Acceleration is downwards 9.8. They have given the time. Time is 5. Then displacement. Displacement is the shortest distance. We are working about the vertical motion. For the vertically, displacement initial point to final point. You can see it has fallen 42.5 meters down when it reached to this point. Therefore, you can write displacement is 42.5. The common question where most of the students ask is what happened to this part of the motion? But this equation is a vector equation and S is the displacement. So whatever the distance traveled over here is not considered when you are considering the displacement. But finally, when you are calculating the time, all of them were counted. Nothing to worry with that. So you just trust me and use apply to the formula. So we will apply the formula upwards direction as positive. It's up to you. Whatever the way you get the same answer. S is, since it's upwards positive, so you can say minus 42.5. U is 0.8 V into time is 5 plus half into minus 9.8 into 5 square. So it's turned up to minus 42.5 4V and over here 0.5 into 9.8 into 25 122.5. Therefore 4V is equals to, so this is minus 122.5. If you brought it to other side, it's 80. Therefore we become 20. We become 20, right? That's how it comes. Then the next fact they are talking about is find the distance from O to A. The O to A means horizontal range. That is, horizontally we assume that there is no acceleration or deceleration. Can apply simply ut. That is 20 cos theta times of time is 5. So it's turned up to 20. Cos theta is 3/5. That is 0.6 into 5. So with that you can obtain the answer as is this way. So we can work out, we'll just work out and see. It's 60 meters. 60 meters, but in this question, they are referring to find the distance from O to A. So you can see over here, this is 42.5 meters, whereas this range is 60 meters. That means they are referring to this distance. So you can simply apply the Pythagoras theorem. So you can write OA equals to square root of 60 squared plus 42.5 squared. So that is the answer for that. So you can get square root of 60 squared plus 42.5 squared. That's a way of doing this question. So you realize that that length become 7, obviously 73.53 meters. So like that you can obtain this answer. That's a way of doing this kind of a question.